This video is going to show you how to use some of the simple to use modules that come standard in the standard Python library. These are not something you have to go grab packages for and install. They should come automatically along, like the math module. They should come with any installation of Python. But they're kind of good for getting a little practice on how to import and use modules and functions and give you a little motivation for why you might want to use them. So the two modules we're going to look at right now are the time module and the OS module. And notice that I can import them all in the same command, just separated by commas. The fact that I get no error says they're successfully imported. And to use the functions of one of these, I have to start, because I didn't give it a nickname here, and I didn't import star like all the functions here, I have to preface every function with the module name. That's not a bad thing, because if I start with the name of the module and I hit tab here, I get a list of all the functions that are available to me. So if I just want to check the time, I can do time.time. Notice the empty parentheses. Why do I need empty parentheses? Well, there's no arguments to put here. I just want to know what time it is. But anytime you use a Python function, you have to have parentheses, whether they have something in them or not. If you ran this without parentheses, Python helpfully tells you that time.time is a function, but it doesn't actually do anything. If I put the parentheses and execute it, it shows me a wonderfully helpful version of the time, which is the number of seconds right now that have transpired since January 1st, 1970 at midnight, which is sort of an origin point called the start of the epoch, or the Unix epoch. And this is sort of a standard measurement in computer science. It's not particularly helpful for, human readable time. If I want that, I can use time.localtime. And that at least gives me, sort of a complicated structure, but it shows me the year, it shows me the month, it shows me the day, etc. This object, this output, is a time object. But you can treat it like a list or a tuple. It's indexable, or it's indexed. So if we do time.localtime, and we use an index, we can get the first thing out of the list. Remember to Python count 0, 1, 2. This is weird looking. This seems like it should be wrong, that you could have empty parentheses followed by square brackets with an index, but that is perfectly legitimate. Let me stick this in a variable so that I have it. And I'm even going to copy this and make variables for the month. Month is in what position? Month is in position 1. And the day. And the day is in position 2. Okay, and if we want to see those, we can do year, month, day, and it will report those out to us. Okay. Those are numeric, by the way. If we want them to be strings, which I do, we could put str on them at this point. And str here. And now, when I report what year, month, and day is, it shows me them as strings. The reason I made them strings, and the reason I bothered to do this, is because sometimes you want to save output files with a timestamp on them. If you're going to be running the same script again and again, and you want to keep track of your versions and what you did on March 20th versus what you did on April 1st, you can create a timestamp. And this would be a string that serves as a suffix. Whatever your file name was, you can stick this timestamp on the end. So let's try and do that. Maybe we'll initiate it with an underscore. And then let's put the day first. then an underscore, and then the month. Oops, we need a plus there. And then an underscore, and then a plus, and then the year. That looks good. Let's take a look at it. See if it looks like we want it to. Yeah. So this would be like a little trailer that you could put on the end of a file to give it a timestamp. The next module I want to look at is OS. So we have OS already imported. We can do OS dot and hit tab to see the sorts of functions that OS contains. OS is a way from right within your Python script to work on your Windows or Mac directory structure. The files and directories that are stored on this computer, this gives you access from within your Python script. So a lot of the functions that you see are going to be about directories. Change directory. Let's find a good one. Oh, list directories. Let's try list directories. List directory does not list the directories, it lists the files in the directory. So whatever directory I currently have this notebook working in, this is a list of all the files that are in it. If I wanted to get all the files in a different directory, right in here I could put, like my desktop. C:\/ users / my ID / desktop. And I have a lot of junk on my desktop, but we could take a look at what it is. Whole bunch of stuff. I gotta clean my desktop. But anyway, that works. We could, instead of listing the directories, we could make a new one. I'm going to copy this so I can use it a little bit later. Down here, I can make, let me add a few blocks so we have some room to work. We can do os.make directory. And on my desktop, I could make a new directory called, let's put it way up at the top. AAAA new directory or something like that. If I execute that, by the way, I'll go back up to my desktop and we can, oh, you know what? Listdir doesn't even show you the directories. We'll look at it through the file system. So here is my desktop. And let's see. Let's get it anew. Maybe we have to refresh it. Right here, we have our new directory. And if I open it, it has nothing in it. So I've made a new directory. If I try to run this again, it will throw me an error because it refuses to make the same directory again. You could remove it. Let's remove, remove. I think this is it. No, I think it's just remove. Oh, I can't remove my desktop. That's terrible. Wait, let's not do that. I'm glad it didn't allow me to do that. New. I guess I have a space in there. I meant to have an underscore. And then maybe it is remove directories. Yeah. So now it's gone. Let's make sure it's gone. It's gone. And we could create it again. Now that it's not there, we could create it again. Let's refresh this. And it's there, okay? We could fill it. Let's fill it with files. Now that we have this directory, let's fill it with files. I'm gonna make this, I'm gonna put this in a variable. So let's have directory that. And then let's put a bunch of files in it and fill them with stuff, and we'll use a loop to do this. Let's make 6 new files. So for I in range, how am I going to get 6 of them? I can go 0 to 6, right? That'll give me 6. 0, 1, 2, 3, 4, 5, and it'll stop right before 6. Or I could do 1 to 7. Let's do 1 to 7. 6 new files. And let's give them a file name. Let's do the directory plus a backslash. Oh, we need an R before this. And let's call them, I don't know, just temp. And let's number them. Okay, so temp, and we'll put a number. Let's use the string of I. So that will, you know, have temp 1, temp 2, temp 3, all the way up to temp 7. And then let's stick that timestamp on there. And a .txt. So that will be 6 new file names. They don't show up in your Windows Explorer because right now file name is just a string. Nothing has happened with it yet. However, once we open it, in such a way as to write it, we can actually write a line to it. What should we write? This is file number I. Okay. Let's give that a try. No error. Let's go explore what showed up in AAA new directory. Now we have 6 files in there, and each one tells you what file number it is. We could also get it by listiers of directory. This will show us the files. Oops, that's because there's no S on listier. There we go. That's all the files that we just created.